Welcome to Lesson 7. We have spent 2 lessons discussing the algebraic operators, and we decided to provide a third because, as they say, three's the charm, and what could be more charming than a striction? Our reason for devoting a whole presentation to the strictions is simply that this is the area of data algebra that is new to everyone who encounters it for the first time. The goal here is to maximize your familiarity with these new operators. Superstriction is the first operator the algebra adds that isn't inherited from set theory, and it behaves unlike anything in SQL. Written with a right-pointing triangle, it takes two relations and asks a single question. Does everything in B also appear in A? If B is a subset of A, then the operator hands back A, whole and unchanged. If it doesn't, there is no result at all. Look at the three cases. B1 sits entirely inside A1, so the gate opens and we get A1. B2 shares a couplet but brings others. A1 hasn't got, so there is no result, or it is undefined. B3 contains all of A1 and one couplet more, so the result is also undefined. We can call these partial operators. Think of superstriction as a gate rather than a filter. It doesn't trim A down, it either passes A through intact or refuses to let it pass. Now let's do this with some real data. Here we use the Outlaws table from the Data Algebra book. It has 5 rows and 6 columns. The SQL we want to imitate selects every outlaw born in New York. And here is the Data Algebra command that does the same work. C equals outlaws, cross superstriction, the clan holding one couplet, New York points to born in. Row by row, that comes down to a plain superstriction of each row against that single couplet relation. So the operator walks the table asking one question of each row. Does this row contain it? Robin Hood was born in Loxley, so no, undefined. Billy the Kid, New York, yes. And the operator hands back the entire row, all 6 couplets, untouched. Al Capone, the same. Loki and Chewbacca fail. 2 rows come back whole. That is precisely what a where clause does. Substriction is superstriction seen in a mirror. The same question asked in the opposite direction. This time we want A to fit inside B. So A substriction B gives you A when A is a subset of B, and nothing otherwise. In the diagram, A2, kernel, seed, root, and germ sits wholly within B4, which holds those 4 couplets and one more. The gate opens, and the result is A2, unchanged. B5 fails because it's smaller than A2, a subset rather than a superset. B6 fails because it swaps in a couplet. A2 doesn't hold. Notice that with both operators, the result, when it's defined at all, is always the left-hand relation, untouched. And that undefined outcome is a genuine nuisance, which is precisely why we lift these 2 up to clans where the awkwardness disappears. So now let us illustrate substriction on the same outlaws table as before. Substriction asks the same question from the other side. The command is p substriction r, where r is row 2 of outlaws. Lifted to the clan, it becomes p cross substriction outlaws. Here is r written out as what it really is, a relation of 6 couplets, Billy the Kid's row. Now we test small relations against it. Murder points to crime, $500 points to reward. Both couplets are in R, so P is a subset of R, and substriction hands P back. Swap in bounty points to reward, and it fails, because bounty is Chewbacca's reward, not Billy's. New York and On the Lam both appear, so that one passes. Billy the Kid with larceny fails because larceny is Robin Hood's crime. Note the real difference. Superstriction returns the row, substriction returns the probe. So, to summarize, restriction, superstriction, and substriction is the where clause made exact. Keep what matches. Lifting turns any relation level verb into a clan level one by applying it to every pair, and we mark it with a broken circle. And the join, that intimidating cornerstone of SQL, is simply restriction and composition, lifted and combined, no magic required. Next time we climb the final rung of the tower and gather clans themselves. In Lesson 8, The Horde. Hopefully you now have a better knowledge of the strictions. Thank you for your time. In Lesson 8 we will climb to the top of the ladder.